Let's practice evaluating an indefinite integral using substitution together. For this particular practice problem, we have the integral of this x squared multiplied by the square root of 5 plus 2x cubed dx. Notice right away that we have basically two functions here. We have this x squared and we have this square root of 5 plus 2x cubed. So when we have these types of integrals where we have two different functions, and in particular this one is a square root function, which can be a little bit tricky, we should maybe think about using substitution. Now when using this u substitution, see which function makes more sense to make u. I think it's going to make a little bit more sense to make this function inside here u, because if we take the derivative of this function, then we're going to see that that 5 is going to go away, and then we're going to have basically 6x squared, and then so the x squared kind of matches this function outside here, so that's going to line up really nicely. And so for this u substitution, let's go ahead and make u equal to this 5 plus 2x to the third power. And that means that du is going to be the derivative of that, which is going to be 6x squared dx. So at this point, we know this 5 plus 2x cubed is going to be right over here. We can replace that with u in a little bit. And then as for this du, we know it's going to be 6x squared dx. We do have this dx here, and we do have the x squared, so we'll have to deal with that 6 in just a little bit. Now we have this radical function here, and this is going to be a little bit tricky to deal with, so let's turn this into exponential form. So remember, when you take the square root of a function, that's basically saying we can raise it to the 1/2 power. So let's rewrite this as x to the second power multiplied by the quantity of this 5 plus 2x to the third power. Let's go ahead and just raise that entire quantity to the 1/2 power. That's going to be an exponential form, and of course we have this dx after. Now before we make our substitution, notice how we have the u perfectly lined up here. This is good. However, for the du, we're kind of missing a little piece here, right? We don't have a 6 in our integral. So to take care of this, see if we can be a little creative here. Let's go ahead and multiply this whole thing by 1/6, and then multiply the whole thing by 6 as well. So again, 1/6 times 6, that's just going to be 1, so we're not really changing the function at all. And here's the rest of the integral. So all we really did was multiply our integral by 1, but you're going to see why in just a moment. Then rearranging this a bit, let's use the commutative property and just rearrange the multiplication. So we can multiply all these together at the end so it matches this du. Rewriting this, we're going to have this 1/6 out in front. We're going to multiply that by the quantity of this 5 plus 2x to the third power, raising that to the 1/2 power, that's the square root. And then we're going to have this 6x squared dx. So here's all that at the end now. So this right here is going to be our u as we defined earlier, and then this right here is going to be our du, which we also had defined earlier. And so everything matches up perfectly except for this 1/6 that we have in front, which is just a constant, so we can put that in front of the integral. So let's go ahead and do that. At this point, let's go ahead and write our 1/6 out in front here of our integral. Then for this 5 plus 2x cubed, let's go ahead and make that substitution. So that's just going to be u. I'm going to go ahead and write a u here. That's raised to the 1/2 power, or the square root of that. And then let's go ahead and replace our 6x squared dx with du here, right? Using that u substitution. So that's going to be du. All right, so now to take the integral of this u to the 1/2 power du. And so if we go ahead and do that, let's just see if we take the antiderivative. Let's go ahead and take that u. We're raising that to the 1/2 power. Now, when we go ahead and take that antiderivative, what do we have to do? We're going to go ahead and just add 1 to the exponent. So 1 plus 1/2 is 1/2, or 3/2. And keep in mind, we're going to go ahead and divide by that exponent. So we're going to divide by 3/2 here. All right. Now, if we go ahead and do that, dividing by 3/2 is the same thing as multiplying by its reciprocal of 2/3. So let's go ahead and rewrite this as 2/3 multiplied by this u raised to the, 1/2 power, or you can also write that as 3/2 power. All right, so that is going to be that antiderivative. Now don't forget we have a plus c, but I'm just going to go ahead and write it over here. So we have 1/6 multiplied by this 2/3 that we just found that's going to be in front, multiplied by u raised to the what? It's raised to the 3/2 power. Let's go ahead and write that exponent in. And then of course we have a lovely plus c at the end we can't forget about. Now just multiplying these two fractions, the 2 and 6 can cross cancel to make 1 and 3. So that's just going to be 1/9 in front here. And then we can go ahead and swap out our u back for this 5 plus 2x to the third power. So let's go ahead and multiply that by the quantity of this 5 plus 2x to the third power. Let's go ahead and put that in a hug here. And then we have that raised to the 3/2 power. And of course we have plus c. All right, so we're almost there here. Let's just go ahead and clean this up just a little bit. So if we want to go ahead and multiply these two fractions, we can multiply and cross cancel the 2 and 6 to make 1 and 3. So we're just gonna have 1/9 in front here. So I'm gonna go ahead and write 1/9. And let's go ahead and substitute back here. So remember, u is equal to this 5 plus this 2x to the third power. So let's go ahead and substitute that back in, give that a hug here. We're gonna say this is going to be this 5 plus this 2x to the third power. That's what it was originally, right? So give that a hug and raise that to the 3/2 power, and then plus c. All right, now that we've resubstituted, this would be the antiderivative for that original integral. Hopefully now that we've gone through an example together, you feel a little bit more comfortable on how to solve these types of indefinite integrals using substitution. If you did, please consider sharing this with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.